Google's new quantum computer has made a groundbreaking announcement that has sent shockwaves through the tech world. Their latest quantum chip has demonstrated performance capabilities that could potentially render NVIDIA's dominance in computing obsolete. This revelation is not just a technical milestone, but a paradigm shift in the competitive landscape of advanced computing. It challenges the status quo of GPU-based computing, which has been central to NVIDIA's success, and introduces quantum computing as a viable contender for the most demanding computational tasks. To understand the significance of this development, we need to dive into the basics of quantum computing and how it differs from classical computing, including NVIDIA's powerful GPUs. Quantum computers operate on quantum bits, or qubits, which leverage the principles of quantum mechanics such as superposition and entanglement. Unlike classical bits, which exist as either 0 or 1, qubits can exist in multiple states simultaneously. This allows quantum computers to process and analyze data at speeds exponentially faster than even the most advanced classical supercomputers. NVIDIA, on the other hand, has been a leader in high-performance computing with GPUs driving advancements in artificial intelligence, machine learning, and data analytics. Their architecture has powered everything from scientific research to gaming and self-driving cars. GPUs are incredibly efficient at parallel processing, enabling them to handle massive amounts of data and complex computations. Until now, NVIDIA has been at the forefront of computational innovation with no real competitors threatening their dominance in these fields. Google's quantum chip, however, changes the game entirely. In a series of tests conducted by Google's research team, their quantum processor demonstrated a level of computational power that could solve problems previously thought to be beyond the reach of classical computing. This leap in performance is not just incremental, but transformative. For tasks such as optimization, cryptography, and material simulation, quantum computing could perform classical GPUs by orders of magnitude. One of the most striking demonstrations of Google's quantum chip was its ability to perform quantum simulations that would take the world's most advanced classical supercomputers thousands, if not millions, of years to complete. These simulations are critical for understanding complex systems in physics, chemistry, and biology. For example, quantum simulations can help researchers design new materials at the molecular level, enabling breakthroughs in energy storage, pharmaceuticals, and industrial manufacturing. NVIDIA's GPUs, while incredibly powerful, are fundamentally limited by the constraints of classical computing. Quantum chips, on the other hand, operate in an entirely different paradigm, unlocking possibilities that were previously unimaginable. This raises a critical question: is this the beginning of the end for NVIDIA's dominance in computing? The answer is complex and multifaceted. NVIDIA's GPUs are not going away anytime soon. They remain indispensable for a wide range of applications, from training AI models to powering graphics-intensive tasks. However, the rise of quantum computing represents a tectonic shift in the industry, one that could redefine what we consider cutting-edge technology. Google's quantum chip is not just about raw power, it's also about efficiency. One of the major challenges in high-performance computing is energy consumption. Data centers around the world consume massive amounts of electricity, much of it dedicated to running and cooling GPUs. Quantum computers, by contrast, have the potential to perform the same or greater levels of computation with significantly lower energy requirements. This could lead to a more sustainable future for computing, addressing one of the most pressing concerns of the modern tech industry. The implications of this breakthrough extend far beyond NVIDIA. Entire industries stand to be disrupted by quantum computing. For example, in finance, quantum algorithms could revolutionize portfolio optimization and risk assessment. In logistics, they could enable unprecedented levels of efficiency in supply chain management. In cybersecurity, quantum computing could both break current encryption methods and create unbreakable quantum encryption, fundamentally altering the landscape of digital security. It's important to note that Google is not the only player in the quantum computing race. Companies like IBM, Microsoft, and Rigetti are also making significant strides in developing quantum technologies. However, Google's latest quantum chip appears to have set a new benchmark, putting them ahead in the race to achieve practical quantum supremacy. This term, coined by Google itself, refers to the point at which a quantum computer can perform a task that no classical computer can achieve in a reasonable time frame. Despite the hype, quantum computing is still in its infancy. There are significant challenges to overcome, including error correction, scalability, and the need for specialized environments to maintain qubit stability. Quantum computers operate at temperatures close to absolute zero, requiring sophisticated cooling systems that are far from practical for widespread deployment. NVIDIA's GPUs, by contrast, are robust, scalable, and compatible with existing infrastructure, giving them a distinct advantage in the near term. Another critical factor is software. Quantum computing requires entirely new algorithms and programming paradigms. While progress has been made in developing quantum software, it is still a new field. NVIDIA, on the other hand, has a well-established ecosystem of tools, libraries, and frameworks that make it easy for developers to harness the power of GPUs. This ecosystem has been a key factor in NVIDIA's success and will continue to be a competitive advantage as quantum computing matures. The competition between Google and NVIDIA also highlights a broader trend in the tech industry, the convergence of hardware and software innovation. NVIDIA's CUDA platform, for instance, has been instrumental in driving GPU adoption for machine learning. Similarly, Google's TensorFlow framework has become a cornerstone of AI development. As quantum computing evolves, the companies that can seamlessly integrate hardware and software will have a significant edge. What does this mean for the future of NVIDIA? While Google's quantum chip poses a potential threat, it also presents an opportunity. NVIDIA has already begun exploring quantum computing, investing in research and development to ensure they remain at the forefront of technological innovation. By leveraging their expertise in GPU use, NVIDIA could play a crucial role in bridging the gap between classical and quantum computing. Hybrid systems that combine the strengths of both paradigms could be the next frontier, enabling unprecedented levels of performance and efficiency. For Google, the challenge will be translating their quantum breakthroughs into practical applications. While their quantum chip represents a significant milestone, it's not yet clear how or when it will impact real-world industries. Achieving this will require not only technological innovation but also collaboration with businesses, governments, and academic institutions to develop use cases and address ethical considerations. As we look ahead, it's clear that the competition between Google and NVIDIA is not just a battle between two companies, but a reflection of the broader evolution of computing itself. From the early days of mainframes to the rise of GPUs and now the advent of quantum chips, each generation of technology has pushed the boundaries of what is possible. Google's quantum chip represents the latest chapter in this ongoing story, challenging us to rethink our assumptions about computation and opening the door to a future filled with new possibilities. The stakes could not be higher. Quantum computing has the potential to unlock solutions to some of humanity's greatest challenges, from climate change to global health. At the same time, it raises profound ethical and societal questions. How will we ensure that the benefits of quantum computing are distributed equitably? What safeguards will we need to prevent misuse? These are questions that will require collective effort and foresight to address. In the meantime, the tech world will be watching closely as Google continues to develop their quantum chip and NVIDIA responds to this new challenge. Whether we are on the brink of a quantum revolution or witnessing the beginning of a new era of hybrid computing, one thing is certain: the race is on, and the future of technology will never be the same. As the world begins to grasp the magnitude of Google's quantum computing achievement, the conversation surrounding its impact continues to evolve. This breakthrough does not exist in isolation. It raises questions about the future of industries, national security, global innovation, and even geopolitical strategies. NVIDIA, while an undeniable leader in GPU technology, now faces an era where quantum computing could completely rewrite the rules of high-performance computing. To understand the scope of this shift, we must explore the broader implications of Google's quantum chip and how this new technology could shape the world over the coming decades. The industry ripple effect. Google's quantum chip introduces a paradigm shift not just for NVIDIA but for the entirety of industries reliant on advanced computing. While NVIDIA GPUs have long served as the backbone for sectors like artificial intelligence, video gaming, autonomous vehicles, and supercomputing, quantum computing presents solutions to problems that were previously considered unsolvable. These problems are not merely theoretical, they underpin many of the most challenging aspects of modern industries. In the financial world, quantum computing threatens to revolutionize the way we analyze and predict markets. NVIDIA's GPUs have been instrumental in the rise of algorithmic trading, allowing firms to execute complex calculations rapidly. However, quantum computing introduces a level of speed and accuracy that could make current systems appear archaic. With its ability to process enormous datasets simultaneously, Google's chip could offer near-instantaneous optimization of financial portfolios, improved risk assessments, and unprecedented accuracy in market predictions. While NVIDIA GPUs will remain valuable in the near future, firms looking for an edge may quickly adopt quantum technology. NVIDIA must now consider how they might adapt their strategies to stay relevant in financial computing, artificial intelligence, and machine learning. Another critical area of overlap is artificial intelligence. NVIDIA's GPUs have long been the hardware of choice for training AI models due to their superior parallel processing capabilities. From powering advancements in natural language processing to enabling breakthroughs in image recognition, NVIDIA has dominated this sector. But Google's quantum chip changes the game entirely. Quantum computing could potentially accelerate AI training processes that take weeks down to mere minutes or hours. Imagine training an advanced neural network in the time it takes to watch a movie, enabling businesses and researchers to iterate faster than ever before. Quantum computing could also unlock entirely new AI architectures, allowing machines to tackle problems of unprecedented complexity. NVIDIA has begun to explore quantum computing partnerships and hybrid models, but their ability to pivot quickly will determine how well they can compete with emerging quantum players like Google. Healthcare and drug discovery, the implications for healthcare are profound. NVIDIA GPUs are currently used for bioinformatics, protein folding simulations, and drug discovery. The groundbreaking AlphaFold project, which predicts protein structures, relies heavily on GPU computing. However, quantum computing offers the ability to simulate molecules and chemical interactions at the quantum level, allowing researchers to design drugs with precision previously unimaginable. With Google's quantum chip, the timeline for developing life-saving medications could shrink dramatically. Diseases that have resisted treatment for decades may finally yield to the power of quantum simulations. NVIDIA's role in healthcare computing is secure for now, but as pharmaceutical companies explore quantum options, NVIDIA will need to demonstrate its ability to integrate with or compete against quantum systems. NVIDIA's countermeasures. NVIDIA is no stranger to competition, and the company is undoubtedly preparing its own response to the rise of quantum computing. While Google's quantum chip currently dominates the headlines, NVIDIA has several strategic options to remain a key player in advanced computing. Hybrid systems. One of the most promising avenues for NVIDIA is the development of hybrid systems that combine classical GPUs with quantum processors. Such systems could offer the best of both worlds, the reliability and scalability of classical computing combined with the revolutionary speed of quantum algorithms. By partnering with quantum computing firms or developing their own quantum hardware, NVIDIA could position itself as a leader in hybrid computing. Quantum-optimized GPUs. Another potential path forward for NVIDIA is the creation of GPUs specifically optimized to interface with quantum systems. These quantum-friendly GPUs could act as a bridge between classical and quantum computing, enabling seamless integration for businesses and researchers. This approach would allow NVIDIA to leverage its existing expertise while staying relevant in the quantum era. Expanding into software, NVIDIA has long recognized the importance of software in driving hardware adoption. Their CUDA platform has been a key factor in the success of their GPUs, enabling developers to easily harness the power of parallel processing. In the quantum computing era, software will be just as critical. NVIDIA could expand into quantum programming frameworks, creating tools that simplify the development of quantum applications. By becoming a leader in quantum software, NVIDIA could maintain a strong presence even as hardware paradigms shift. National security and geopolitical implications. Google's quantum chip breakthrough also has significant implications for national security. Quantum computing is a double-edged sword. It offers tremendous potential for solving complex problems, but it also poses a serious threat to cybersecurity. Current encryption methods, which rely on the difficulty of solving mathematical problems, could be rendered obsolete by quantum algorithms. This has led to a global race to develop quantum-resistant encryption. With countries like the United States and China investing heavily in quantum research, NVIDIA's GPUs have been a critical asset in the defense sector, powering simulations, data analysis, and AI systems for military applications. As quantum computing gains traction, the defense industry will need to adapt. NVIDIA has an opportunity to collaborate with governments and defense contractors to develop hybrid systems that integrate quantum capabilities while maintaining the robustness of classical systems. Google's quantum chip also raises questions about technological leadership on the global stage. The United States has long been a leader in advanced computing, but countries like China are rapidly catching up. If quantum computing becomes the new frontier of innovation, maintaining a competitive edge will require significant investment and collaboration between private companies, governments, and academic institutions. Ethical and societal considerations. While the technical and economic implications of Google's quantum chip are enormous, we must also consider the ethical and societal challenges that come with such transformative technology. Quantum computing has the potential to disrupt entire industries, create new forms of inequality, and challenge existing regulatory frameworks. Accessibility and equity. Who will have access to the power of quantum computing? If quantum technology remains confined to a few large corporations and wealthy nations, it could exacerbate existing inequalities. NVIDIA has played a role in democratizing advanced computing by making GPUs accessible to a wide range of developers and researchers. As quantum computing evolves, ensuring equitable access will be critical to its success. Ethical AI. Quantum computing could accelerate the development of AI systems, but this raises ethical concerns. Faster AI training could lead to more powerful models, but it could also exacerbate issues like bias, surveillance, and job displacement. Companies like Google and NVIDIA will need to work with policymakers and ethicists to ensure that their technologies are used responsibly. Environmental impact. While quantum computing offers the promise of lower energy consumption, the development and maintenance of quantum systems still require significant resources. NVIDIA has made strides in creating energy-efficient GPUs, but the industry as a whole must prioritize sustainability as computing demands continue to grow. The road ahead, as we move into a future shaped by quantum computing, one thing is clear: the competition between Google and NVIDIA is just beginning. Google's quantum chip represents a major milestone, but it is not the end of the story. NVIDIA's ability to adapt, innovate, and collaborate will determine its place in the next chapter of computing history. For Google, the challenge will be translating their quantum breakthroughs into practical applications. While their quantum chip is a remarkable achievement, it is not yet clear how or when it will impact real-world industries. Achieving this will require not only technological innovation but also collaboration with businesses, governments, and academic institutions. The broader implications of this competition extend far beyond Google and NVIDIA. Quantum computing has the potential to redefine the way we approach some of humanity's greatest challenges, from curing diseases to combating climate change. At the same time, it raises profound questions about ethics, equity, and security. In the end, the story of Google's quantum chip and NVIDIA's response is not just a tale of technological rivalry but a reflection of the broader evolution of computing itself. From the early days of mainframes to the rise of GPUs and now the advent of quantum chips, each generation of technology has pushed the boundaries of what is possible. As we stand on the cusp of a quantum revolution, the future of computing has never been more exciting or more uncertain. Let me know if you'd like to explore any specific aspects further.